All right, so as we continue with our partial fractions here, we just finished up splitting up this relatively complicated partial fraction. We had an irreducible quadratic term and then a repeated linear term. Gave us four variables. We got a nice little system here. It worked out well, as examples typically do. And so if we see here, now we're going to try and integrate this. So we're integrating this quadratic or this rational function that we had up here. Let's go ahead and write it out. It would be, see, how do I want to do this? I'll write it neatly. You might want to write a little bit small to have plenty of space. When we break it down, we would get, let's see here. Here's all my variables, 2 and then 1. So 2x plus 1 over x squared plus 1 plus, or I guess I could have done minus 2 over x minus 1. That's all right. It's just a fraction. X minus 1 squared, and then this is all dx. Now, just knowing how this works out, I know that I'm going to separate these two. One thing that stands out to me that's on why I would do this without just having the experience is if I cover up the x squared here, 1 over x squared plus 1, I see that as inverse tangent. So we know that right away we can do that integral. Then we'd have to look at the 2x on the top to see how we can do that. So what I'm going to do is I'm going to make each one of these a different color just so we can see it easily. So I'm going to break this up and we're going to have 2x over x squared plus 1. That's going to be one of our fractions. Then 1 over x squared plus 1. That's another one of our fractions. Then the ones that we already have here, minus 2 over x minus 1 and 1 over x minus 1 squared. So each one of these we're going to integrate and then add them together. Okay. So when we do this first one, we would have u equals x squared plus 1 du equals 2x dx. So there's our u du, there's our u. It would be 1 over, this becomes 1 over u du. The next term becomes plus, like we already said, this was inverse tangent of x. Make that an n instead of a u. This next one is natural log, so we get minus 2 natural log of the absolute value of x minus 1. And the next one has a u substitution. Du minus 1 du equals dx, so that's an easy substitution. That becomes the integral of 1 over u squared du. So when we put it all back together, this is natural log of the absolute value of x squared plus 1, which I guess we don't need the absolute value, that's always positive, plus the inverse tangent of x, minus 2 times the natural log of the absolute value of x minus 1. We do need the absolute value here because that's not always positive. This would become u to the negative 2. We'd add 1, multiply by reciprocal. We get 1 over x minus 1. And then, of course, we would never forget our plus c, right? We get that. Now, again, these are kind of fun puzzles. It's interesting to be able to do all this a few times, so you don't have many homework problems on this. It's just to practice and get an idea of what techniques are out there. We've got a last one here, which uses a slightly different way of finding a, b, and c. So let's look at this, and then we'll be done. So we have x squared plus 1 over, and this is cubic over under the x squared, so we'll be fine. It's proper. We have a over x minus 1 plus b over x minus 2 plus c over x minus 3. So we multiply this out, we get x squared plus 1 equals a. Now x minus 1 is going to cancel, so we have x minus 2, x minus 3. On the b, the x minus 2 cancels, and we have x minus 1, x minus 3. And then on the c, the last one cancels, and we have x minus 1, x minus 2. Now, instead of going by foiling these out and going by x squared, x, and constants, we just need 3 equations. And this has to be true for any x value. So I'm going to pick x values, 3 x values that are going to make this easy. I'm going to pick them and then let you see if you can figure out why I picked the numbers I did. If I pick x equals 1, that implies that the left is going to be 1 squared plus 1 equals a times, let's see, that's going to be 1 minus 2 is negative 1, 1 minus negative 3 is negative 2. Then this is plus, 1 minus 1 is 0, 0. 1 minus 1 is 0, plus 0. That should be a big hint on why I chose 1. So 1 squared plus 1 is 2. Negative 1 times negative 2 is 2, so we get 2a. So 2 equals 2a implies a equals 1. So the next one I'm going to guess is, any guesses, is, yeah, we're going to let x equals 2. So we get 2 squared plus 1 equals, that's going to be 0 here. Then we have a b times, plugging in 2, we get 2 minus 1 is 1. 2 minus 3 is negative 1. And then the last term is 0. So we get 5 equals negative b. So b is, that implies that b is negative 5. Did I do that right? Looks right. And then x equals 3 implies 3 squared plus 1 equals 0 plus 0 plus c times 2 times 1. So this becomes 10 equals 2c. So that implies that c equals 5. So our answer, or our partial fractions, are 1 over x minus 1 minus 5 over x minus 2 plus 5 over x minus 3. And so those all work out. Those would be easy integrals. Those would just be natural logs. And that's just another way of creating the 3 equations you need to find the 3 variables. So try the homework. I believe there's 4 where you just do partial fractions, and there's 4 where you do the partial fractions and then integrate. So have them as a little fun little challenge and enjoy the last assignment of the year. Remember, on Friday I need you to write a letter to next year's class on how to survive and thrive in calculus, and get that to me. Let me know if you need copies from previous years to see how they formatted, but it's completely up to you. I don't change anything other than maybe making it 1 page or formatting like that. So let me know what you need. It's been a great year. Talk to you soon.